This is Professor Derf Seitz. This video shows how to do hypothesis testing for homogeneity using Microsoft Excel. The idea here is to look at two populations and to determine how distinct characteristics are distributed across the two of them, whether or not they share the same distribution of these characteristics or not. It's very similar in setup to a hypothesis test for independence using two contingency tables, an observed value table and an expected value table. In the contingency table up here with the blue cells, one of the rows is for one of the populations and the columns are the characteristics, and the other row is for the other population with its corresponding characteristics. The blue area is set up to allow 5 rows by 5 columns. This example uses 2 rows by 4 columns, and it's important that the unused inactive cells are blank, which will result in zeros in the corresponding expected value cells. Each expected value here is calculated as looking at its corresponding observed value up here, and then it's the row total for that value times the column total for that value, that product divided by the overall total over here in the lower right. These are column totals, these are row totals here. So the expected values are calculated. For blank cells, they come out to 0, which does not affect anything. The two hypotheses, the null hypothesis, is that the proportion of each population sharing specified characteristics is the same. And the alternative is that the proportion of each population sharing specified characteristics is different. There's a check that needs to take place in order for this test to be valid. For each of the active expected values, its value must be greater than or equal to 5. We see that condition is met for this example. This blue cell here, you enter your level of significance. In this example, it's 1%. It's shown with 5 decimal places of precision to make it easy to compare to the p-value. The p-value has a blue comment reminding that there's a change necessary in this formula. The function used for the p-value is chi-squared test with 2 ranges. First range is for the observed value contingency table, the active cells, and the second one is for the corresponding expected value cells. Notice A2 to D3, that's this 120, and then you want to select that. We drag from there down to the 25, which is at D3. That would select this entire active rectangle here. Similarly, down here. So you must set that appropriately. Now we get our result. Microsoft Excel does the test and provides the p-value. We see that the p-value is less than alpha. It's less than or equal to, so it's in this case less than. That means there is enough evidence, because we have such a small probability here, to reject the null hypothesis, which is what was assumed for making these expected values. We reject it at the 1% level of significance, and then we decide that the proportion of each population sharing specified characteristics is different. or many problems that students will need to solve of this type, they will be asked to provide the actual test statistic in addition to the p-value. This second tab here does all the calculations for you necessary to calculate the test statistic. However, there's two cells that you must enter the rows and columns of the contingency table, the active cells, 2 by 4. You must enter that over here. Then the degrees of freedom is automatically calculated, rows -1 times columns -1. The observed values and the expected values are copied for you over here, all of them, even the inactive ones, which show up as zeros. Those zeros do not affect anything in the final statistic because it's adding things together. These three columns progressively calculate towards the necessary final test statistic. First, the difference between the observed and expected for each row here, then the square of that in this column, and then that square divided by the expected value in this last column, and the sum of this last column is the test statistic. And the p-value is not copied from the previous tab. It's recalculated using chi-square distribution right tail, passing in test statistic, H5, and the degrees of freedom. And notice the p-value is 0.00110. That's what we got over here on the first tab, doing it with a different function. That's a strong indicator that everything was done correctly, and we can now finalize this decision.